Tonight, you are about to see your home in a way most people never truly do. Not your house, not your city, not even your planet. Your real home, a galaxy 100,000 light-years wide, holding between 200 and 400 billion stars. And beyond it, an ocean 93 billion light-years across, filled with nearly 2 trillion galaxies. If you've ever wondered just how small and how extraordinary you truly are, this is the journey you don't want to miss. Welcome to Velarin, Sleepy Space Mysteries, where curiosity slows to the rhythm of a quiet breath, and science becomes a gentle doorway into perspective. Tonight, we won't rush through numbers. We'll feel them. We'll compare a single spiral galaxy to the observable universe itself, and step by step, we'll let the scale settle softly around us. Before we drift outward, subscribe, like this video, turn on the notification bell, and join our membership if you'd like to keep exploring the cosmos in calm company. And tell me in the comments, where are you listening from tonight? I'd love to see just how far this journey travels across our own small world. Now take a slow breath. Let's begin inside the Milky Way. Take a slow breath, and instead of looking up at the Milky Way, imagine you are already inside it. Because you are. We are not observers standing outside some distant spiral of light. We are embedded within it, gently orbiting inside a vast, rotating city of stars. The Milky Way is what astronomers call a barred spiral galaxy. If you could step far above it and look down, you would see long, curved arms winding outward from a bright central region. Across its full diameter, from one faint edge of the disk to the other, it stretches about 100,000 light-years. A light-year is the distance light travels in a single year, moving at about 300,000 kilometers per second. So when we say 100,000 light-years, we are describing a distance so large that even light itself would need 100,000 years to cross from one side to the other. And yet, for all that width, the galaxy is surprisingly thin. The main disk, the glowing plane where most of the stars reside, is only about 1,000 light-years thick. If the Milky Way were scaled down to the size of a large dinner plate, its thickness would be thinner than a sheet of paper. Wide and delicate, broad and almost impossibly slim. We live within that thin layer, suspended in a slowly turning spiral. At the very center lies a bright, swollen region known as the central bulge. Hidden inside that bulge is something both powerful and quiet. A supermassive black hole called Sagittarius A star. It contains about 4 million times the mass of our Sun. 4 million suns compressed into a region smaller than our solar system. And yet it does not roam through space like a monster. It sits calmly at the center, its gravity helping to anchor the motion of billions of stars orbiting around it. We are not near that center. Our solar system resides in a smaller spiral segment known as the Orion Arm, sometimes called the Orion Spur. We orbit roughly 27,000 light-years from the galactic core, not too close to the intense radiation and gravitational turbulence of the central bulge, not too far out into the sparse edges of the disk. We occupy a quiet middle suburb of this galactic city. Picture it like this. If the Milky Way were a vast glowing metropolis seen from above at night, The central bulge would be its brilliant downtown. The spiral arms would be sweeping highways of light, and our solar system would be a calm neighborhood street, circling peacefully along with billions of other homes. Inside this city of stars, astronomers estimate there are between 200 billion and 400 billion stars. Even the lower number is difficult to grasp. 200 billion suns. And our sun is just one of them, one ordinary star among hundreds of billions. Most of those stars are not like our sun. About 75% of them are red dwarfs. These are smaller, cooler, dimmer stars that can burn for trillions of years. They glow softly, steadily, conserving their fuel. Our bright yellow sun is actually somewhat larger and more luminous than the majority of stars around us. And yet, when you step outside on a clear, dark night, how many stars can you see with your unaided eyes? At most, across the entire sky, about 6,000. That is all human vision can capture without telescopes. 6,000 visible points of light out of hundreds of billions that belong to our galaxy alone. It is like standing in the center of a vast forest and seeing only the nearest few trees. Modern instruments have expanded our view. The European Space Agency's Gaia spacecraft has mapped the positions and motions of over 1 billion stars in the Milky Way. 1 billion carefully measured points of light, each with distance, motion, and brightness recorded. And even that enormous catalog represents only a fraction of the galaxy's full population. As we drift here inside the spiral, notice the feeling this creates. The Milky Way is not just a distant object we look at in photographs. It is the structure that holds us. Every star you have ever seen in the night sky belongs to this single galaxy. Every constellation, every faint band of light stretching across a dark summer sky, every meteor flashing briefly overhead. All of it unfolds within this 100,000 light-year wide home. We are not lost in the universe. We are located. We have an address. Orion Arm 27,000 light-years from the center. Inside a thin, luminous disk that turns slowly through space. And as you breathe gently, imagine that slow rotation continuing. Steady, silent, patient, carrying our sun and Earth along with billions of neighboring stars in a quiet, graceful orbit around the center of the Milky Way. Now let's stay inside this spiral a little longer and allow time itself to unfold around us. The Milky Way is not only vast in space, it is ancient in age. Astronomers estimate that our galaxy formed roughly 13 billion years ago, not long after the universe itself began. For nearly the entire history of the cosmos, this great barred spiral has been turning, gathering stars, forming planets, quietly evolving in the dark. When the Milky Way was young, it was smaller and more chaotic, shaped by collisions and mergers with smaller galaxies. Over billions of years, it grew into the structured spiral we inhabit today. Our sun, by comparison, is only about 4.5 billion years old, meaning it was born long after the Milky Way had already settled into its mature form. We arrived late to an already ancient city of light. Our solar system orbits the center of the galaxy once every 230 million years. To make that number easier to feel, imagine this. When dinosaurs first walked the Earth, our solar system was in a completely different region of the Milky Way. Since life began on our planet, Earth has completed only about 20 full orbits around the galactic center. 20 slow, enormous loops across hundreds of millions of years each. Entire species rise and vanish in the time it takes to complete just a fraction of one galactic year. Continents drift. Ice ages come and go. Civilizations appear and fade. All while the sun continues its steady path around Sagittarius A star, pulled gently by gravity in a vast circular journey that feels almost eternal compared to a human lifetime. And yet, despite this immense scale, the motion is calm. Our solar system moves through the galaxy at roughly 220 kilometers per second. That sounds fast, faster than any aircraft ever built, but we do not feel it. There is no wind of stars rushing past us, no sensation of speed, because everything around us, every nearby star, every cloud of gas, is moving in the same grand rotation. It is like being on a smoothly moving train in the dark. Inside, everything feels still even though you are traveling at extraordinary speed. The Milky Way is not just a rotating disk of visible stars. Surrounding the thin disk and central bulge is something far more mysterious. A vast halo extending far beyond the bright spiral we picture in photographs. This halo may stretch 300,000 light-years or more from the center. That means the true gravitational reach of the Milky Way could be 3 times wider than the visible disk. The halo contains sparse stars and ancient globular clusters, dense spherical groups of old stars that orbit high above and below the galactic plane. But most of the halo's mass is not made of stars at all. It is made of dark matter. Dark matter does not shine. It does not reflect light, cannot be seen directly, and yet its gravitational influence outweighs all the visible stars, gas, and dust combined. When astronomers measure how quickly stars orbit in the outer parts of the galaxy, they find something unexpected. The stars move too fast. If only visible matter were present, the outer stars should drift away into intergalactic space. Instead, they remain tightly bound, moving in stable orbits. The only explanation is that there is far more mass present than we can see. This unseen mass forms an invisible scaffold, a gravitational framework that holds the Milky Way together. In a very real sense, most of our galaxy is invisible. The glowing spiral arms, the bright band across the sky, the billions of stars we can measure, all of that is only a small fraction of the total mass. The majority lies hidden in the dark halo, shaping the motion of everything within it. So when we imagine the Milky Way as a luminous city suspended in space, we must also imagine an enormous invisible structure surrounding it, like a transparent sphere of gravity extending far beyond the lights. The visible disk is only the bright core of a much larger, unseen whole. This changes how we think about the galaxy's edge. The bright spiral arms may end around 100,000 light-years across, but the gravitational boundary extends much farther. Objects within roughly a few 100,000 light-years remain bound to the Milky Way's pull. Beyond that, space truly begins to belong to the wider cosmos. And here is the quiet beauty in all of this. We are not floating randomly through an empty void. We are embedded inside a structured, rotating, gravitationally bound system that has existed for billions of years. We are part of a stable orbit that has carried life through cosmic time. The thin disk beneath us, the halo around us, the dark matter holding everything together, all of it works silently, invisibly, continuously. When you step outside at night and see that faint milky band stretching across the sky, you are looking along the plane of this disk from the inside. You are seeing the crowded lanes of this star city edge on. You are not outside peering in. You are inside, looking through the lights of your own home. Let that settle for a moment. The Milky Way is not a distant object. It is the structure that holds your planet, your sun, your entire history. And as it turns slowly through space, you turn with it, completing another tiny fraction of a 230 million year orbit, gently circling the center of a galaxy that has been shining for 13 billion years. Let's drift even deeper into this quiet city of light and feel its scale not just in distance, but in population. Between 200 billion and 400 billion stars live inside the Milky Way. Even the lower estimate means that for every person on Earth, there are dozens of suns scattered across our galaxy. If you tried to count them at 1 star per second without sleeping, it would take you more than 6,000 years to reach 200 billion. The number is so large that it stops behaving like an ordinary number. It becomes a landscape, and yet most of these stars are invisible to us. On a perfectly dark night, far from city lights, you might see a few thousand stars overhead. Across the entire sky, both hemispheres combined, the human eye can detect only about 6,000 stars in total. That is all. 6,000 bright neighbors out of hundreds of billions that share the same galactic home. What you see with your eyes is a tiny sampling, like standing in the middle of a vast forest and noticing only the trees nearest to you. The reason is simple. Most stars are faint. About 75% of all stars in the Milky Way are red dwarfs. These small, cool stars glow softly in deep shades of red and orange. They burn their fuel slowly and can live for trillions of years, far longer than our sun ever will. They are quiet, steady, enduring, but because they shine so dimly, most are invisible without powerful telescopes. If your eyes were sensitive enough to see every red dwarf around us, the night sky would look unimaginably crowded, dense with countless faint embers. Our sun, by comparison, is somewhat brighter and more massive than most stars. It is not rare, but it is not typical either. It belongs to a smaller group of medium-sized stars that shine steadily for billions of years. And around this one star, on a small rocky planet in the Orion Arm, awareness emerged. That alone is extraordinary. Out of hundreds of billions of stars, one has given rise to beings capable of mapping the galaxy that surrounds them. Modern astronomy has begun to chart this immense population. The Gaia spacecraft has measured the positions, distances, and motions of more than 1 billion stars in the Milky Way. 1 billion carefully mapped points of light. And yet, that enormous catalog still represents only a fraction of the galaxy's total. It is like mapping every house in a single neighborhood of a city that stretches across an entire continent. The more we measure, the more we realize how much remains unseen. But the Milky Way is not just a collection of isolated stars. It has structure. The spiral arms are regions where gas and dust gather more densely, forming waves of star formation that sweep through the disk. New stars are born in glowing clouds called nebulae, where gravity pulls hydrogen gas together until nuclear fusion ignites in the core of a newborn sun. These stellar nurseries are scattered throughout the spiral arms, quietly replenishing the galaxy with fresh light. Meanwhile, older stars drift into more stable orbits, circling the center in elongated paths that carry them above and below the thin disk. Some gather in globular clusters, spherical swarms of ancient stars that orbit in the halo. These clusters are among the oldest objects in the galaxy, formed more than 12 billion years ago. They are relics from the Milky Way's early days, still circling patiently after billions of years. When we speak of the Milky Way as 100,000 light-years across, it is easy to let the number blur. But try to feel it in layers. If you could travel at the speed of light, the fastest speed allowed by physics, it would take you 100,000 years to cross from one side to the other. 100,000 years ago, humans were still in the early stages of migration across continents. Entire chapters of human history would unfold before light itself could complete the journey. And yet the galaxy does not feel chaotic. It feels balanced. Every star, including our sun, follows a predictable orbit shaped by gravity. The disk rotates as a whole like a slow-turning wheel. We are passengers on that wheel, carried gently along without sensation of motion. Our solar system drifts through interstellar space surrounded by a vast, thin medium of gas and dust. Occasionally, it passes through denser regions. Occasionally, nearby stars shift slightly in relative position over millions of years. But on human timescales, the sky appears almost fixed, constant, reassuring. This stability is part of what makes the Milky Way feel like home. It is not a violent storm of stars crashing into one another. Despite containing hundreds of billions of suns, the distances between them are enormous. If our sun were the size of a small coin, the nearest star would be several kilometers away. The galaxy is crowded in number, but spacious in layout. Stars almost never collide directly. They dance around one another in wide, elegant arcs. And above and below this luminous disk, the dark matter halo continues its silent work, outweighing all visible matter and ensuring that the outer stars remain bound. Without that invisible mass, the spiral would unravel. The city of light would slowly disperse into the void. Instead, it holds together, turning steadily through cosmic time. We are not outside this structure. We are embedded within it. Every atom in your body was once part of a star somewhere in this galaxy. The carbon in your cells, the oxygen in your lungs, the iron in your blood. All were forged in stellar cores and scattered by supernovae long before Earth formed. The Milky Way is not just our address in space. It is our origin story written in light. So as you rest here, imagine the disk stretching above and below you, 1,000 light-years thick, 100,000 light-years wide, containing hundreds of billions of suns. Imagine the halo extending even farther, 300,000 light-years or more, wrapped in invisible dark matter. Imagine the central bulge glowing softly around Sagittarius A star, and then picture our small solar system quietly orbiting 27,000 light-years from the center, completing one gentle lap every 230 million years. This is not a distant abstraction. This is your home, and if you are still drifting through the Milky Way with me, type 1 in the comments so I know you're still traveling. Before we ever zoom outward to other galaxies, let's pause again and feel what it truly means to live inside this one. The Milky Way is not simply large. It is layered, structured, quietly organized across scales that range from the intimate to the immense. From the surface of Earth, it can appear as nothing more than a pale band of mist stretching across the night sky. But that faint glow is actually the side view of our own galactic disk, seen from within, where billions of distant stars overlap into a soft river of light. Imagine standing in the middle of a vast forest at night. If you shine a flashlight straight ahead through the densest part of the trees, you see layer after layer of trunks, fading into darkness. That is what happens when we look along the plane of the Milky Way. Our line of sight travels through tens of thousands of light-years of stars packed within the thin disk. But when we look upward, out of the plane, the stars thin out. The forest opens. The sky becomes darker and more spacious. That contrast is not random. It is geometry. We are embedded inside a flattened spiral, and our view reflects that shape. The thin disk, about 1,000 light-years thick, contains most of the galaxy's stars, gas, and dust. Within it, spiral arms curve gently outward from the central bar. These arms are not solid structures but regions of higher density, like traffic waves moving along a highway. Stars pass through them, gas compresses within them, and new stars ignite inside, glowing nebulae scattered along their curves. Our Orion arm is one of these smaller segments, tucked between larger arms named Perseus and Sagittarius. It is not the grandest highway of the galaxy, but it is stable and relatively calm. That quiet may be part of why life had time to emerge here. Closer to the center, the density increases. The central bulge holds older stars packed more tightly together. There, the gravitational pull is stronger and stellar interactions are more frequent. Orbiting deep within that region is Sagittarius A star, the 4 million solar mass black hole anchoring the galaxy's core. It does not dominate the entire galaxy the way black holes are often imagined in fiction. Its gravitational influence is strongest near the center, but at our distance of 27,000 light-years, it is simply one component of a much larger gravitational balance. Beyond the visible disk lies the halo, extending perhaps 300,000 light-years from the center. Within it drift sparse stars and ancient globular clusters, each cluster a tight sphere containing hundreds of thousands of very old stars. These clusters orbit high above and below the disk, tracing long arcs shaped by the invisible mass of dark matter. That dark matter halo outweighs all visible matter combined. It forms the true gravitational backbone of the Milky Way. Without it, the galaxy would not hold together. The outer stars would drift away, and the spiral structure would dissolve over time. Think about that for a moment. Most of our galaxy is invisible. The luminous spiral we admire in photographs is only the glowing frosting on a much larger, unseen structure. Dark matter shapes the rotation curve of the galaxy, keeping outer stars moving at speeds that would otherwise fling them into intergalactic space. The visible disk may be 100,000 light-years across, but the gravitational influence stretches much farther, blending gradually into the broader cosmic environment. The Milky Way is also not static. Over billions of years, it has grown by absorbing smaller dwarf galaxies. Streams of stars from those past mergers still wrap around the halo like faint ribbons, evidence of ancient collisions. Even now, the Milky Way continues to interact gravitationally with nearby dwarf companions. These subtle interactions slowly reshape the halo and disk, adding to the layered history written in stellar motions. And yet, despite these grand processes, our local neighborhood remains serene on human timescales. The nearest star beyond our sun is more than 4 light-years away. Most stars are separated by vast distances compared to their size. If our sun were the size of a basketball, the nearest star would be thousands of kilometers away. The galaxy is crowded in number, but spacious in reality. Stars almost never collide directly. Instead, they glide past one another in enormous, slow arcs dictated by gravity. Our solar system is part of that gentle flow. Moving at about 220 kilometers per second around the galactic center, we complete one orbit every 230 million years. That means since the formation of Earth, we have circled the galaxy roughly 20 times. 20 vast galactic years. Life on Earth has unfolded within that rhythm, carried along by a motion so smooth we cannot feel it. The Milky Way is about 13 billion years old. That makes it nearly as old as the universe itself. It has witnessed the birth and death of countless stars. Entire generations of suns have lived and faded within its spiral arms. Some ended quietly as white dwarfs. Others exploded as supernovae, scattering heavy elements into interstellar space. Those elements later formed new stars and planets, including Earth. In that sense, the Milky Way is not just our home. It is our ancestor. This is why belonging is not poetic exaggeration. It is literal. Every atom in your body was once part of a star within this galaxy. The iron in your blood was forged in stellar cores. The carbon in your cells was created through nuclear fusion in ancient suns. The oxygen you breathe was released by long-dead stars billions of years ago. You are not separate from the Milky Way. You are assembled from it. And so, as you rest here inside this spiral, imagine the quiet order of it all. The thin disk rotating slowly, the spiral arms guiding waves of star birth, the halo extending far into darkness, the dark matter holding everything together like an invisible scaffold. Our sun orbiting steadily in the Orion arm, Earth turning gently beneath you. You are not floating alone in empty space. You are embedded within a structured, ancient, luminous system that has endured for 13 billion years. This galaxy is not overwhelming. It is spacious. It is steady. It is home. And we are still inside it, drifting peacefully along its slow, silent rotation. Before we prepare to leave this spiral behind and step outward into the wider universe, let's take one final, steady look around from inside. Not from above, not from outside, but from here within the disk where we truly live. Imagine the Milky Way not as a diagram in a textbook, but as a living environment. A quiet, rotating city of light suspended in deep darkness. Hundreds of billions of stars spread across 100,000 light years, each one following its own orbit, each one moving in patient harmony with the gravitational rhythm of the whole. The thin disk, only about 1,000 light years thick, glows softly in layered lanes of starlight. The central bulge shines brighter, dense with older suns. Far beyond the visible glow, the halo stretches outward for perhaps 300,000 light years or more, wrapped in invisible dark matter that outweighs everything we can see. And here we are, not at the center, not at the edge, but in a stable middle region about 27,000 light years from the core, riding along in the Orion Arm. Our solar system has been circling the galaxy for 4.5 billion years, completing about 20 full orbits since Earth formed. Each orbit takes roughly 230 million years. Civilizations rise and fall in the blink of a galactic year. Ice ages come and go in less than a fraction of a single rotation. The galaxy does not rush. It does not flicker in and out. It turns slowly, almost imperceptibly, like a great wheel whose motion can only be measured across millions of years. The stars do not crowd one another. Though there are hundreds of billions of them, the distances between them are vast. Space inside the Milky Way is mostly empty. A thin scattering of atoms, faint dust, gentle magnetic fields. The crowded appearance in photographs is a trick of distance and perspective. In reality, even within this immense star city, there is room, breathing room. This spaciousness is important. The galaxy is large, but it is not chaotic. The scale does not crush us, cradles us. The gravitational balance of visible matter and dark matter holds everything together in a steady dance. Sagittarius A star anchors the center with its 4 million solar masses. Yet its influence at our distance is simply part of a broader equilibrium. The halo extends outward, unseen but essential, ensuring that the outer stars remain bound. The spiral arms continue to nurture new suns, even as older ones fade. If you could rise above the plane of the disk and look back, you would see the Milky Way as a luminous spiral suspended in darkness. But from here, inside it, what you see is different. You see a sky filled with stars. You see a faint band of light arcing overhead. You see constellations that humans have named and renamed for thousands of years. You do not see the whole spiral at once. You experience it from within, like walking inside a vast cathedral without ever stepping outside to view its exterior. And yet, you do not need to step outside to belong. You already do. There are between 200 and 400 billion stars here. 75% are red dwarfs, dim and long-lived. Only about 6,000 stars are visible to your naked eye from Earth. Gaia has mapped more than 1 billion stars, and still that is only a fraction of the total. The numbers are enormous, but they are not abstract. They describe the environment that holds you at this very moment. When you breathe in, the oxygen filling your lungs was forged in a star. When your heart beats, the iron that carries oxygen through your blood was created in a supernova somewhere in this galaxy billions of years ago. When you look up at the night sky, you are not gazing at something separate from yourself. You are seeing the larger structure from which you are made. The Milky Way is not merely a background. It is the context of your existence. It defines the gravitational neighborhood of Earth. It shapes the radiation environment that allowed life to evolve. It provides the heavy elements necessary for planets and biology. It has been turning for 13 billion years, and for a brief moment within that immense span, you are here, aware inside it. And perhaps that is the most grounding thought of all. We are not drifting alone in meaningless emptiness. We are embedded within a stable, ancient, luminous system. We have a galactic address. Orion Arm 27,000 light-years from the center. Inside a thin disk rotating once every 230 million years. Surrounded by hundreds of billions of neighboring suns. The Milky Way is large, yes, but it is also intimate. It is the scale at which the universe first begins to feel like a place. Not yet the overwhelming vastness of trillions of galaxies. Not yet the 93 billion light-year diameter of the observable universe. Just this spiral, this home, this quiet city of light. And as we prepare to zoom outward in the next part of our journey, carry this feeling with you. The Milky Way is not something we must conquer or fully comprehend to belong. It is already carrying us, already holding us in its slow orbit, already turning beneath our lives with calm, patient motion. If you're still drifting through the Milky Way with me, type 1 in the comments so I know you're still traveling. Now we begin to drift outward. Not quickly, not all at once, just a gentle widening of perspective. Our nearest great neighbor is the Andromeda Galaxy. It rests about 2.5 million light-years away. When you hear that number, let it breathe. 2.5 million years for light itself to cross the distance. The glow reaching your eyes from Andromeda tonight began its journey long before the first humans walked the earth. Before language, before cities, before memory, Andromeda is similar in size to the Milky Way. Another vast spiral city of stars. If our galaxy is about 100,000 light-years across, Andromeda stretches to a comparable scale, perhaps slightly larger. Two giant spirals suspended in darkness, slowly approaching one another. We are not alone out here. The Milky Way and Andromeda are part of a small family called the Local Group. More than 50 galaxies share this quiet gravitational neighborhood. Most are small dwarf galaxies, faint and easily overlooked. But together they form a community, bound gently by gravity across millions of light-years. Picture it like islands scattered across a calm sea, each island glowing softly, each separated by enormous distances, yet still connected through the invisible pull of mass and motion. And this quiet neighborhood is not static. Andromeda is moving toward us, very slowly, about 100 kilometers per second. That sounds fast, but across cosmic scales it is patient, unhurried. In about 4 billion years, the Milky Way and Andromeda will begin to merge. Not a violent crash of stars colliding, but a slow gravitational dance. Stars are so widely spaced that direct collisions are unlikely. Instead, the galaxies will stretch, twist, and reshape each other over hundreds of millions of years. Our night sky will change. Constellations will blur and reform. Eventually, the two spirals may settle into a single, larger elliptical galaxy. A new home formed from two ancient ones. For billion years. That is roughly the current age of Earth itself. Long after our sun has begun to change. Long after humanity in its present form is only a memory in stone. Pause there. 2.5 million light years to Andromeda. 4 billion years until merger. More than 50 galaxies in our local group. And we are just getting started. Now we widen the lens again. Beyond our local group lies something larger, clusters. Gravity gathers galaxies the way gravity gathers stars. One of the nearest large collections is the Virgo cluster. It lies about 65 million light years away. 65 million. When the light now reaching us from Virgo first began its journey, dinosaurs still walked the Earth. The Virgo cluster contains more than 1,000 galaxies. Spirals, ellipticals, irregular shapes, all orbiting within a shared gravitational well. Our local group itself is moving gently toward this cluster, part of a larger cosmic flow. Let that number settle. 65 million light years. We have moved from millions to tens of millions. Zoom out again. The Virgo cluster is not isolated. It is part of something even larger, a supercluster. Our home supercluster is called Laniakea. The name means immense heaven. It spans roughly 500 million light years across. 500 million light years from edge to edge. Inside Laniakea are around 100,000 galaxies. 100,000 galaxies. If each galaxy contains hundreds of billions of stars, then within this single supercluster alone there are numbers so large they slip beyond everyday intuition. And yet Laniakea is just one region among many. Pause again. The Milky Way, 100,000 light years across. The local group, millions of light years wide. The Virgo cluster, 65 million light years away. The Laniakea supercluster, 500 million light years across. Each step outward adds silence before the next number. And still, we have not reached the true large-scale structure of the universe. If you could rise even higher beyond clusters and superclusters, you would not see a uniform fog of galaxies. You would see a pattern. Vast filaments stretching across space. Long, thread-like structures where galaxies gather along invisible lines of gravity. Between those filaments lie enormous voids, regions with very few galaxies at all. This structure is often called the cosmic web. Imagine dew forming along the strands of a spider web at dawn. The strands are the filaments, the droplets are galaxies, and the dark spaces between are mostly empty. Most of the universe is empty space. Not empty in the sense of nothing at all, but empty compared to the glowing density of galaxies. The average distance between galaxies is immense. Even within clusters, space dominates. Galaxies are like islands in a vast ocean, and we are on one of those islands. Let that feeling stay gentle. Not smallness, not insignificance, just perspective. We have moved from our spiral home to our neighboring galaxy, to our cluster, to our supercluster, to the web itself. And still, we have not reached the edge. Now we continue outward, but more slowly than you might expect. Before we reach the largest scale, we need to understand how we even know these distances at all. Because none of this is guessed. None of it is imagined loosely. It is measured carefully, step by step, using light itself as our guide. Think of light as a messenger. Every star, every galaxy, every cluster sends light outward in all directions. That light travels across space at a fixed speed, about 300,000 kilometers per second. Fast enough to circle Earth 7 times in a single second. But even that speed becomes small when distances stretch into millions and billions of light years. The first rung of our measuring ladder is something simple called parallax. If you hold your finger in front of your face and close one eye, then the other, your finger appears to shift against the background. Astronomers use the same idea with nearby stars. As Earth moves around the Sun, nearby stars appear to shift slightly against more distant ones. By measuring that tiny shift, astronomers can calculate how far away those stars are. This works beautifully for stars within a few thousand light years. Beyond that, the shift becomes too small to detect. So we climb to the next rung. There are special stars called Cepheid variables. These stars pulse in brightness with a steady rhythm. And remarkably, the period of that pulse is directly related to their true brightness. If you know how bright a star truly is, and you see how bright it appears from Earth, you can calculate its distance. Cepheid variables allow us to measure distances to nearby galaxies, including Andromeda. Then we climb higher still. There are certain stellar explosions known as type Ia supernovae. These explosions reach nearly the same peak brightness every time. They become cosmic beacons, visible across billions of light years. By comparing how bright they appear to how bright they should be, astronomers measure distances far beyond our local region. And then comes redshift. As the universe expands, it stretches the light traveling through it. Wavelengths become longer. Colors shift toward red. The greater the redshift, the farther away the galaxy. This discovery revealed something astonishing. The universe is expanding. Galaxies are not drifting randomly through static space. Space itself is stretching, carrying galaxies with it. So when we measure distant galaxies, we are not only measuring distance. We are measuring motion. We are measuring history. We are watching the fabric of the universe grow. Now let us use those tools to zoom outward again. The observable universe is defined by time. The universe is about 13.8 billion years old. That means light has had 13.8 billion years to travel since the beginning. But because space has been expanding during that entire time, the most distant objects we can see are not 13.8 billion light years away today. They are now about 46 billion light years away. That is the observable radius. 46 billion light years in every direction. which means the observable diameter is roughly 93 billion light-years across. Pause there. The Milky Way is about 100,000 light-years across. The observable universe is 93 billion light-years across. Divide 93 billion by 100,000 and you get roughly 900,000. The observable universe is about 900,000 times wider than our galaxy in diameter. Let that comparison settle slowly. If the Milky Way were the size of a coin, the observable universe would be nearly the size of a continent. But diameter is only part of the story. Volume grows with the cube of size. When you compare volumes, the observable universe is roughly 1 quintillion times larger than the Milky Way. That is 10 to the 18th power. A 1 followed by 18 zeros. A billion times larger in volume. Now consider population. Our galaxy contains between 200 and 400 billion stars. That feels immense. But within the observable universe, estimates suggest there are around 2 trillion galaxies. 2 trillion. And if each galaxy holds on average 100 billion stars, then the total number of stars approaches 10 to the 24th power. A septillion stars. A 1 followed by 24 zeros. If every star were a grain of sand, the beaches of Earth would not be enough. Now pause again. We began in one spiral galaxy, 100,000 light-years across. We stepped to Andromeda at 2.5 million light-years. We widened to the local group of more than 50 galaxies. We expanded to the Virgo cluster 65 million light-years away. We opened to Laniakea at 500 million light-years across. We traced the filaments of the cosmic web. And now we stand at the edge of the observable universe. 46 billion light-years outward in every direction. 93 billion light-years across. 2 trillion galaxies. Around a septillion stars. And beyond that, we do not know. The observable universe is not the entire universe. It is simply the portion whose light has had time to reach us. Beyond our horizon, space likely continues, perhaps endlessly, perhaps repeating similar structures, perhaps not. We cannot see beyond that limit because light from farther regions has not yet arrived. So here we are, suspended in a galaxy that is one of trillions, inside a universe nearly 1 million times wider than our home galaxy, surrounded mostly by emptiness, threaded by filaments of light. The numbers are vast, but let them remain gentle. You are not lost in this scale. You are part of it. Every atom in your body was forged inside a star. Every breath you take carries elements born in stellar cores. You are not separate from this cosmic ocean. You are made of it. And somehow, within all this vastness, consciousness arose. In one spiral arm of one galaxy among trillions, matter became aware of itself. That awareness is happening now. Through you, let that thought soften everything. The universe is 93 billion light-years across, and yet it is experienced from one small, quiet point inside it. Here, if you are still here at the edge of the observable universe with me, type 2 in the comments so I know you are still traveling. Now that we are standing at the edge of the observable universe, It may feel as though we have reached the final boundary. 93 billion light-years across. 2 trillion galaxies. A septillion stars. It sounds complete. It sounds final. But there is something subtle here. The observable universe is not the whole universe. It is only the portion whose light has had time to reach us. Imagine standing in a vast fog. You can see in every direction, but only out to a certain distance. That distance does not mean the world ends there. It simply marks how far your vision can travel. In the same way, the observable universe is a horizon created by light and time. Light travels at a fixed speed. The universe has a finite age. Those two facts combine to create a boundary around us. Beyond it, space almost certainly continues. We simply cannot see it yet, or perhaps ever. And this brings us to something even more profound. The universe is not only expanding. Its expansion is accelerating. In the 1920s, astronomers discovered that distant galaxies are moving away from us. The farther away they are, the faster they recede. This was the first hint that space itself is stretching. But in the late 20th century, observations of distant supernovae revealed something unexpected. The expansion is speeding up. Galaxies are not just drifting apart. They are accelerating away from one another. This acceleration is attributed to something we call dark energy. We do not yet know what dark energy truly is, but it appears to make up about 70% of the total energy content of the universe. It acts like a kind of pressure woven into space itself, pushing it outward. The result is that very distant galaxies are receding from us faster than the speed of light. Not because they are moving through space that fast, but because space between us and them is expanding so rapidly. This creates something called a cosmic event horizon. There are galaxies whose light from billions of years ago can still reach us. We see them as they were long ago, but the light they are emitting today will never arrive. It will never bridge the expanding gulf. Those galaxies are already beyond our future reach. Over vast stretches of time, even more galaxies will slip beyond that horizon. Trillions of years from now, observers in our region of space may see only the merged remnant of the Milky Way and Andromeda. The wider cosmic web will fade from view. The cosmic microwave background, the afterglow of the Big Bang, will stretch and thin until it becomes undetectable. We live in a rare era of cosmic visibility. The universe is old enough for structure to have formed, but not so old that expansion has erased the evidence. This moment right now is a window in which the cosmos reveals itself. Let that thought settle gently. We are not only small in space, we are brief in time, and yet we exist at a moment when the universe can be known. Now let us return to scale once more, but this time with calm repetition. The Milky Way, 100,000 light-years across. The observable universe, 93 billion light-years across. That means the universe is about 900,000 times larger in diameter than our galaxy. If you imagine shrinking the Milky Way to the width of your hand, the observable universe would stretch nearly the distance of a continent. And when you think in terms of volume, the comparison becomes almost unimaginable. 1 quintillion times larger, 10 to the 18th power. The difference is not incremental. It is exponential. It is the difference between a pond and an ocean without shore. And yet, both the pond and the ocean are made of the same substance. The Milky Way and the universe are not fundamentally different in composition. The same physical laws govern both. Gravity shapes galaxies and clusters. Dark matter provides unseen structure. Dark energy drives expansion. The same atomic forces that bind hydrogen in distant galaxies bind the atoms in your body. The difference between galaxy and universe is not a difference of material. It is a difference of scale. Think of a wave on the surface of the ocean. The wave rises and falls, has shape and motion, a beginning and an end. But the ocean beneath it stretches far beyond that wave. The wave is not separate from the ocean. It is the ocean expressed locally. In the same way, the Milky Way is a local expression of the universe, a gravitationally bound region within a much larger expanding fabric. The universe is not simply bigger than our galaxy in the way a large building is bigger than a room. It is bigger in a structural sense. The galaxy is a bound system. The universe is the stage on which bound systems exist. One is shaped by gravity pulling inward, the other by expansion pushing outward. That difference in governing force creates the enormous contrast in size. Now breathe into that perspective. We live inside a galaxy that feels immense to us. 100,000 light years is far beyond any journey we could undertake. Our solar system alone would take tens of thousands of years to cross at light speed. And yet, our galaxy is just one island in a cosmic ocean nearly 1,000,000 times wider. The vastness does not erase our significance. It reframes it. We are small compared to the galaxy. The galaxy is small compared to the universe. And yet we can hold all three in thought. That is extraordinary. Somewhere within a spiral arm of a typical galaxy among trillions, consciousness emerged. Matter arranged itself in such a way that it could ask about its own origin. The universe is 93 billion light years across, and it is being contemplated from one quiet planet. Let that be enough. The scale is immense. The silence between galaxies is vast. The expansion continues steadily, but you are not outside of it. You are part of it. The atoms in your body were forged in ancient stars. The energy that powers your thoughts comes from nuclear fusion in our sun. The same physics that shapes clusters shapes you. Rest in that continuity. Rest in the idea that you are not an observer standing apart from the universe, but a participant inside it. A temporary arrangement of cosmic matter aware of its own vastness. The universe is spacious, not crushing. It is wide enough to hold trillions of galaxies and still allow room for quiet. Wide enough to stretch for 93 billion light years and still be experienced from a single breath. And here, at this quiet edge of the observable horizon, the numbers no longer need to grow. They can simply settle. From this quiet edge, where the observable universe stretches 93 billion light years across, something changes. The journey outward is complete, but the journey inward begins. Because once you truly feel the scale, the question shifts. It is no longer only how big is the universe compared to our galaxy. It becomes, what does that size mean for us? When you first hear that the observable universe is about 900,000 times wider than the Milky Way, it can feel overwhelming. The mind tries to picture it and fails. 100,000 light-years across for our galaxy. 93 billion light-years across for the observable universe. The difference is not just large. It is almost abstract. But abstraction softens when we remember something simple. Scale does not determine meaning. The Milky Way is tiny compared to the universe. Earth is microscopic compared to the Milky Way. You are microscopic compared to Earth. And yet meaning flows upward from the smallest scales, not downward from the largest. The universe does not experience itself at 93 billion light-years wide. It is experienced locally, through stars, through planets, through living systems, through awareness. Right now, the entire observable universe is being experienced from one small point in space. Through you. Think about that gently. The cosmos does not feel large to itself. It feels large to us. And that perception is intimate, not distant. The atoms that make up your body were forged in stellar cores billions of years ago. Hydrogen formed in the first minutes after the Big Bang. Carbon was created in red giant stars. Iron was forged in supernova explosions. Those elements traveled across space, mixed into new clouds, collapsed into our solar system, formed Earth, and eventually formed you. When you look outward at galaxies billions of light-years away, you are looking at relatives, distant cousins made of the same ancient matter. The universe is not a foreign object you are studying. It is your extended structure. And this is where the vastness becomes something spacious rather than crushing. Space is not crowded. Most of it is empty. Between galaxies lie millions of light-years of near vacuum. Spacious. That spaciousness is not hostile. It is breathing room. If the cosmos were compressed, if galaxies were tightly packed together, collisions would be constant and violent. Stability would be rare. Instead, the wide gaps allow structure to persist. The emptiness is not a flaw. It is a feature. It allows islands of light to shine distinctly. In that same way, the vastness of the universe allows us room to exist. Room to evolve, room to reflect. When we say the universe is expanding, we are not saying it is racing toward destruction. We are saying it is creating more space, more room between galaxies, more distance across which light travels, more history unfolding. The expansion does create limits. There are galaxies whose present light will never reach us. There are regions permanently beyond our future horizon. But this does not diminish what we can see. It makes our current view precious. We live in a rare epoch. The cosmic microwave background, the faint afterglow from when the universe was only about 380,000 years old, is still detectable. Galaxies are still close enough to observe their motion clearly. The large-scale structure is still visible. In trillions of years, observers may see far less. The sky may grow darker as distant galaxies slip beyond the event horizon. But now, in this window of cosmic time, the universe is revealing itself. That awareness should not create urgency. It should create gratitude. We are not late to the story. We are not early. We are here at a moment when the cosmos can be understood. And understanding it does not require crossing those 93 billion light years. It requires patience, curiosity, light. Now return once more to the comparison. The Milky Way, 100,000 light years across. The observable universe, 93 billion light years across. That ratio of roughly 900,000 to 1 can feel disorienting. But imagine it differently. Imagine the Milky Way as a single musical note. The observable universe is the entire symphony. The note is not less meaningful because it is brief. It is part of the composition. Without notes, there is no symphony. Without galaxies, there is no universe. And without observers, there is no awareness of either. The scale difference is not a hierarchy of importance. It is a layering of structure. Stars form galaxies. Galaxies form clusters. Clusters form superclusters. Superclusters form the cosmic web. The web fills the observable universe. And within that web, within one spiral arm of one galaxy, life emerged. The entire 93 billion light-year span does not reduce that fact. It amplifies it, because the larger the stage, the more remarkable it is that awareness appears anywhere at all. The universe is vast enough to contain trillions of galaxies, yet subtle enough to produce consciousness. Vast enough to stretch for billions of years, yet precise enough to allow chemistry and biology to unfold. When you rest beneath that understanding, the scale stops feeling threatening. It begins to feel generous. The cosmos is not a tight enclosure pressing inward. It is an open field stretching outward. The emptiness between galaxies is like silence between notes. Necessary, allowing structure to breathe. And you are here in that openness. A temporary, luminous arrangement of atoms shaped by gravity, chemistry, and time. The universe does not need you to be large to belong. It only needs you to exist. As we sit here at the quiet edge of scale, the numbers can soften. 93 billion light years becomes not a distance to travel, but a context to appreciate. 2 trillion galaxies becomes not a crowd, but a reminder of abundance. A septillion stars becomes not an overwhelming count, but a testament to possibility. The Milky Way is small compared to the universe. You are small compared to the Milky Way, and yet here you are, aware of all of it. That is not insignificant. That is astonishing, and in that astonishment, there is rest. And now, after traveling from our spiral home to the edge of the observable universe, we allow everything to settle. We began inside a galaxy 100,000 light-years wide. We drifted to Andromeda at 2.5 million light-years away. We widened to the local group of more than 50 galaxies. We stepped into the Virgo cluster 65 million light-years distant. We opened into Laniakea, stretching 500 million light-years across. We traced the cosmic web, filaments threading through vast voids. And finally we stood at the observable 93 billion light-years across. Along the way, the scale grew layer by layer, each step adding silence before the next number. Now we are here, not at a physical edge, but at a horizon of understanding. The observable universe is about 13.8 billion years old in time, yet 93 billion light-years wide in space because expansion has been stretching distances from the beginning. Inside this bubble lie roughly 2 trillion galaxies. Inside those galaxies, perhaps around 10 to the 24th stars, a septillion points of light, and among those countless stars, on a small rocky world orbiting an ordinary sun in a typical spiral galaxy, awareness emerged. It is easy to feel small at this scale. The Milky Way is about 900,000 times smaller in diameter than the observable universe. In volume, the difference grows to about a billion times larger. The numbers are staggering. But notice something gentle in that comparison. Even though the universe is almost 1,000,000 times wider than our galaxy, it is not separate from it. The Milky Way is not sitting outside the universe. It is inside it, and we are inside the Milky Way. The part is contained within the whole, and the whole expresses itself through its parts. The universe does not diminish the galaxy by being larger. It gives it context, just as the ocean does not diminish a wave by being vast. The wave is the ocean briefly shaped. The Milky Way is the universe, locally gathered by gravity into structure. And you are the universe, locally gathered into awareness. The difference in scale does not reduce meaning. It shifts perspective. When you think about 93 billion light-years, do not try to picture the entire distance. Let it be what it is, a measure of how far light has traveled since the beginning. When you think about 2 trillion galaxies, do not try to count them. Let it be what it is, a reminder that the cosmos is abundant beyond imagination. When you think about 10 to the 24th stars, do not try to hold the zeros in your mind. Let it be what it is, a sign that possibility multiplies across space. The universe is vast, but it is not chaotic. Structure emerges at every level. Stars gather into galaxies. Galaxies gather into clusters. Clusters gather into superclusters. Superclusters trace filaments in the cosmic web. And that web stretches across the observable universe. Patterns repeat across scale. Order appears within openness. The emptiness between galaxies is not a void of nothingness, but the spaciousness that allows structure to exist. If everything were compressed tightly together, there would be no room for complexity, no room for stability, no room for time to unfold. The wide gaps are what make the luminous islands visible. In the same way, the vastness of the universe gives room for life to arise quietly on one small planet. As we close this journey, return to the simplest comparison. The Milky Way, 100,000 light-years across. The observable universe, 93 billion light-years across. The ratio, about 900,000 to 1. That difference may seem enormous, but it is simply the difference between a local structure and the total region we can observe. It does not measure importance. It measures scale. Scale is about size. Meaning is about experience. And experience happens locally, right here, in one mind reflecting on galaxies billions of light years away. The universe does not need to shrink for you to matter. It does not need to be smaller to feel intimate. It is intimate already because you are part of it. The same physical laws shaping galaxy clusters shape your heartbeat. The same atoms forged in ancient stars compose your cells. The same expansion stretching space outward has carried your entire cosmic history forward to this moment. You are not standing beneath the universe as something separate. You are within it, of it, a brief but real expression of its long unfolding. Let the numbers fade now. Let 93 billion light years soften into a feeling of openness. Let 2 trillion galaxies soften into a sense of abundance. Let a septillion stars soften into quiet wonder. The journey from galaxy to universe was not meant to overwhelm. It was meant to widen perspective gently, layer by layer. From our spiral home to the cosmic web. From the local group to the observable horizon. From 100,000 light years to 93 billion. And through every step, one truth remains steady. We are inside it all. If you are still here at the edge of the observable universe, still resting in this widened perspective, type 2 in the comments. Not as a test, but as a quiet signal that you made the journey from one galaxy to the vast horizon beyond. Now let your breathing slow. Imagine the Milky Way arching softly overhead. Imagine Andromeda glowing faintly across 2.5 million light years. Imagine clusters and filaments stretching into the dark. Imagine the observable universe, 93 billion light years wide, holding all of it gently within its expanding reach. And remember, the cosmos is vast, but it is not distant. It is the context in which you exist. It is the fabric from which you are woven. It is spacious enough to hold trillions of galaxies and still allow room for stillness. Rest there. There was a moment in the early 20th century when our picture of the universe quietly changed forever. Until then, many believed the Milky Way was the entire cosmos, a single grand island of stars suspended in darkness. Then Edwin Hubble began measuring faint smudges of light in the sky and discovered something astonishing. Those smudges were not clouds inside our galaxy. They were other galaxies entirely, unimaginably distant. And more than that, almost all of them were moving away from us. Not drifting randomly, not circling, receding. The light from those galaxies was stretched toward the red end of the spectrum, a phenomenon called redshift. When light stretches, its wavelength becomes longer. And when nearly every distant galaxy shows the stretching, it tells a simple, breathtaking story. Space itself is expanding. It is not that galaxies are flying through space like sparks from a firework. It is that the space between them is growing. Imagine small dots drawn on the surface of a balloon. As the balloon inflates, each dot moves away from every other dot. None of them are at the center. The surface itself is expanding. In much the same way, our universe has been expanding for nearly 13.8 billion years. The farther away a galaxy is, the faster it appears to recede. This relationship became known as Hubble's law. In simple terms, Speed equals distance multiplied by a constant expansion rate. If a galaxy is twice as far away, it moves away twice as fast. 3 times as far, 3 times as fast. It is a gentle mathematical rhythm woven into the structure of reality. At first, scientists assumed this expansion might slow down over time. Gravity, after all, pulls matter together. With enough mass, perhaps the universe would gradually decelerate, maybe even collapse back inward one day. But in the late 1990s, new observations revealed something unexpected. The expansion was not slowing. It was accelerating. Galaxies are not merely drifting apart. They are separating faster and faster as time passes. Some unseen influence is pushing space outward, overcoming gravity on the largest scales. We call this influence dark energy. Dark energy does not glow. It does not cluster like stars or galaxies. It does not form structures. Instead, it appears to be a property of space itself, a subtle energy embedded within the vacuum. When space expands, more space exists. And if energy is tied to space, then more energy appears as well. That additional energy fuels further expansion. Today, dark energy makes up roughly 70% of the total energy content of the universe. Ordinary matter, the atoms in stars, planets, oceans, and your own body, accounts for only about 5%. Dark matter, invisible but gravitationally powerful, contributes about 25%. And the rest, the dominant majority, is this quiet, expansive force, 70%. That means most of what shapes the large-scale fate of the cosmos is something we cannot see directly. Yet its effects are measurable in the motion of galaxies across billions of light years. If that sounds unsettling, let it soften instead into wonder. The expansion of the universe is not chaotic. It follows consistent patterns. It is measurable, predictable. It unfolds with a calm mathematical steadiness. And here is something even more profound. This expansion does not tear apart galaxies. It does not rip apart solar systems. It does not stretch you. On small scales, gravity and other forces are stronger than cosmic expansion. The Milky Way remains bound together. Our solar system remains stable. Atoms remain intact. Expansion dominates only across vast distances where gravity grows weak. The universe is stretching, yes, but it is not unraveling. It is becoming more spacious. Picture the observable universe as it was billions of years ago. Denser, brighter, galaxies closer together. Over time, space has opened like a slow breath. The distances between clusters have widened. Cosmic structures drift farther apart. Darkness expands between islands of light. But darkness here does not mean absence. It means room. Room for galaxies to evolve. Room for stars to form and fade. Room for planetary systems to arise in quiet corners. Room for consciousness to emerge and ask questions about it all. Expansion is not an explosion frozen in time. It is an ongoing process. Even now, as you rest and listen, the fabric of space stretches by tiny increments. Galaxies millions of light years away are slightly farther apart than they were a moment ago. The change is imperceptible on human scales. but across cosmic distances, it shapes the destiny of everything. And yet, within this expanding vastness, you remain here, grounded, held by gravity, nested inside a galaxy that orbits calmly within a cluster, within a supercluster, within an expanding universe. The cosmos grows larger, but you are not lost inside it. You are carried within its unfolding. As space continues to expand, it introduces a concept that feels almost poetic in its quiet finality: the cosmic event horizon. We are familiar with horizons on Earth. Stand on a shoreline and the ocean appears to meet the sky at a distant edge. Walk toward it and it recedes. It is not a wall, but a limit defined by perspective. The cosmic event horizon is similar, yet far more profound. It marks the boundary beyond which events can never influence us, no matter how long we wait. Because the expansion of the universe is accelerating, there are galaxies so distant that the space between us and them is growing faster than light can travel. Not because they are moving through space too quickly, but because space itself is stretching too rapidly for their light, emitted today, to ever bridge the gap. Imagine a beam of light leaving a distant galaxy right now. It begins its journey toward us at 300,000 kilometers per second. But as it travels, the space between us expands. If that expansion outpaces the light's progress, the beam will never arrive. It will be carried backward, not physically reversed, but outpaced by the growing fabric of space. This is not speculation. According to current measurements of dark energy and the expansion rate, many galaxies we can see today are already beyond this event horizon. We see them as they were billions of years ago, because their ancient light had enough time to reach us. But the light they are emitting at this very moment will never arrive. Their present and future are permanently beyond our reach. There is something sobering about this realization. The universe is filled with galaxies, yet much of it is already inaccessible. Over vast spans of time, even more will slip beyond visibility. In tens of billions of years, observers within our local group will see a very different sky. The Milky Way and Andromeda, likely merged by then into a single larger galaxy, will remain visible. But distant clusters will fade. Their light will stretch into longer wavelengths, eventually beyond detectability. The cosmic microwave background, now a faint whisper from 380,000 years after the Big Bang, will also redshift and fade into silence. Future astronomers may have no observational evidence of the expanding universe at all. They may look outward and see only darkness beyond their own galactic neighborhood. This leads to a remarkable conclusion. We live in a rare era of cosmic visibility. The universe is old enough for complex structures to have formed, for stars to have lived and died, for heavy elements to have seeded planets and life. Yet it is still young enough that distant galaxies remain observable, that the afterglow of the Big Bang can still be measured, that expansion can still be detected through redshift. We stand in a narrow window between opacity and disappearance. Early in cosmic history, the universe was too hot and dense for light to travel freely. Only after about 380,000 years did atoms form and light begin its long journey. That ancient light now fills space as the cosmic microwave background, a faint radiation detectable in every direction. It is the oldest light we can see, a photograph of the universe when it was still an infant. But in the far future, even that light will be stretched beyond detectability. The universe will become observationally quieter. The sky will darken not because galaxies cease to exist, but because they will lie beyond the reach of light. This perspective changes how we think about time. We often imagine the past as distant and the future as open. Cosmology suggests something subtler. The past is visible because its light has already arrived. The distant future, however, will not reveal more structure but less. The observable universe will not grow richer in visible galaxies indefinitely. Eventually, expansion ensures that much of what exists will drift beyond contact. And yet, this does not diminish the present. It makes it precious. We are living in a moment when the universe is still readable. The cosmic web is still mapped. Distant superclusters still glow faintly in deep field images. The faint afterglow of creation still hums across the sky. Our telescopes can still collect photons that have traveled for billions of years. This is not guaranteed forever. It is a temporary clarity. There is a gentle comfort in this realization. We are not at the center of the universe. We are not privileged in location, but we are fortunate in timing. The cosmos has unfolded long enough to produce complexity, and not yet expanded so far that it hides its own history. The event horizon is not a wall closing in. It is a reminder that existence is dynamic. The universe is not static scenery. It evolves. It stretches. It changes what can be seen. Galaxies beyond our horizon are not lost in a tragic sense. They simply belong to regions of space that no longer share causal connection with us. They continue to exist, to form stars, perhaps to host planets and life. We just will never exchange light with them again. If this feels lonely, let it soften. Within our local group, gravity remains stronger than expansion. The Milky Way, Andromeda, and dozens of smaller galaxies are gravitationally bound. We are not being torn apart. On scales that matter to us, structure endures. Expansion acts only across the vastest gulfs. In a sense, the universe is both expanding and holding, stretching outward in spaciousness while keeping local islands of light intact. The event horizon, then, becomes less a symbol of loss and more a symbol of scale. It marks the limit of influence, not the end of existence. It reminds us that reality is larger than what we can touch, larger than what we can see, and yet still coherent. The cosmos is not closing in. It is opening outward, and within that opening we remain here, in a rare era when the sky is still rich with distant light. When we step back from expansion and horizons and consider the long arc of time, something quietly extraordinary comes into focus. We live in a rare era of cosmic visibility. The universe is 13.8 billion years old. For nearly its first 380,000 years, it was opaque, a hot plasma where light could not travel freely. Then atoms formed, the fog lifted, and photons began their journey across space. Those photons still reach us today as the cosmic microwave background, a faint glow in every direction, a whisper from when the universe was young. That ancient light is not dramatic. It does not blaze like a star. It hums softly at microwave frequencies, detectable only with sensitive instruments. And yet it carries a complete map of early structure, tiny fluctuations that would eventually grow into galaxies, clusters, and the cosmic web. We can see it now because we live at a time when it has cooled into detectability but not yet stretched into oblivion. Billions of years from now, that glow will fade beyond reach. It will redshift into wavelengths too long to measure. Future observers may never know it existed. They may not know the universe had a beginning in the way we understand it. They may look outward and see only their own merged galactic remnants surrounded by darkness, unaware of the vast structures that once filled the sky. Our moment, then, is not only small, it is fortunate. We exist after structure has formed, but before it has disappeared from view. Galaxies are still visible in the billions. Clusters still trace the web. The expansion can still be measured through redshift. The cosmic microwave background still glows. This balance will not last forever. The universe is not becoming more crowded with visible galaxies. It is becoming more spacious, and as it does, the sky slowly empties. This does not mean the universe is dying in any immediate sense. Stars will continue to form for trillions of years. Galaxies will merge and reshape, but observational richness will decline. Light will stretch. Signals will fade. The cosmos will grow quieter. And so we find ourselves in a window, not at the beginning, not at the end, but at a time when the universe is readable. There is a strange comfort in this thought. We are not too early to understand. We are not too late to observe. We stand in the middle of the unfolding story, with just enough information reaching us to reconstruct what came before and to infer what lies ahead. When we ask why the universe is so much larger than a galaxy, part of the answer lies here. The universe is defined by expansion. Galaxies are defined by gravitational binding. A galaxy is a region where gravity has pulled matter together strongly enough to resist expansion. Stars orbit within it. Gas clouds collapse into new suns. Dark matter forms a halo that holds structure intact. Inside a galaxy, gravity wins. On the largest scales, expansion wins. The universe as a whole is not bound together the way a galaxy is. It does not orbit a center. It does not hold itself in a fixed shape. It stretches. It grows. It is defined not by containment but by motion outward. This difference explains the immense contrast in scale. A galaxy is a bound system, limited by the reach of its dark matter halo and the balance of gravity and motion. The universe is unbound on large scales, limited only by the age of expansion and the speed of light. One is local structure, the other is the fabric itself. You might think of a wave and an ocean. A wave has shape. It has a crest and a trough. It rises and falls within certain limits. But it exists because of the ocean beneath it. The ocean is vast, not defined by the shape of any single wave. The Milky Way is a wave, immense to us, structured, gravitationally held together. The universe is the ocean, expansive, stretching, not confined to any single form. The ocean is not larger because it is trying to dwarf the wave. It is larger because the wave is a pattern within it. In the same way, galaxies are patterns within expanding space. They are concentrations within something far greater. The difference in size is not an accident. It is intrinsic to the relationship between part and whole. When we accept this, the scale begins to feel less crushing and more spacious. The universe is not overwhelmingly large in a way that diminishes us. It is large because it must be, because expansion has been unfolding for billions of years. Galaxies are small by comparison because they are bound islands within that expanding sea. The emptiness between them is not wasted space. It is breathing room. This spaciousness changes how vastness feels. It is easy to hear that the observable universe is 93 billion light-years across and imagine an oppressive immensity. But another way to see it is as openness. The cosmos is not cramped. It is not crowded edge to edge with matter. Most of it is space, quiet, thinly filled, gently stretching. The vastness is not pressing down. It is opening outward. And within that openness, there is room for complexity to arise. Room for galaxies to form and evolve without constant collision. Room for planetary systems to stabilize. Room for life to emerge in calm corners. The same expansion that carries galaxies beyond our horizon also provides the spaciousness that makes structure possible. It is not merely distance. It is architecture. The universe is bigger than a galaxy because it is the stage on which galaxies appear. Because it has been expanding long enough to create scale beyond imagination. Because gravity binds locally while expansion governs globally. Because part and whole are different by nature. And because spaciousness is written into the physics of reality. We are small within that spaciousness. But small does not mean lost. It means situated. A wave within an ocean. A structure within expansion. A conscious presence within a vast unfolding. And in this era, this rare window of visibility, we can see enough of the ocean to know we belong to it. When we allow all of this to settle, expansion, horizons, rare eras of visibility, the difference between waves and oceans, something quiet begins to form. Vastness does not have to mean insignificance. Humility does not require erasure. The universe is immense, yes. 93 billion light-years across in what we can observe. Trillions of galaxies. More stars than grains of sand on every beach on Earth. And yet, none of that cancels you. In fact, it is what makes your awareness remarkable. You are a conscious arrangement of atoms forged in ancient stars. The carbon in your cells was once inside a stellar core. The oxygen you breathe was released by long-dead suns. The iron in your blood was born in a supernova explosion billions of years ago. When massive stars reached the ends of their lives, they scattered heavy elements into space. Those elements drifted through interstellar clouds, were gathered by gravity, formed new stars and planets, and eventually became part of a small rocky world orbiting an ordinary star in a spiral arm of the Milky Way. From that world, chemistry became biology. Biology became consciousness. And now consciousness contemplates the universe that made it. This is not poetry. It is physics unfolding over time. You are not separate from the cosmos. You are one of its processes. The universe is not only something you look at. It is something you are. When we say the observable universe is 93 billion light-years wide, we are describing scale. But that scale is experienced only through awareness. Without observers, distance is just geometry. With observers, it becomes wonder. The vastness is filtered through your perception, your imagination, your ability to sit quietly and think about it. In that sense, the entire observable universe is experienced within the space of your mind. That does not shrink it. It highlights the extraordinary nature of awareness. You are small in size, yes, but you are not small in significance. Significance is not measured in kilometers or light years. It is measured in experience. A galaxy does not know it is large. A star does not know it is burning. But you know that stars burn. You know that galaxies drift. You know that space expands. The universe becomes meaningful through consciousness. This realization brings a different kind of humility. Not the humility of being crushed by scale, but the humility of participation. You are part of something unimaginably vast, and that vastness has, through countless processes, given rise to you, not as an accident without context, but as a natural outcome of cosmic evolution. Hydrogen formed in the early universe. Gravity gathered it into stars. Stars fused it into heavier elements. Supernovae scattered those elements. Planets formed. Chemistry became complex. Life emerged. Awareness opened its eyes. At no point did the universe step outside itself to create something foreign. It simply continued unfolding. And here you are, an arrangement of matter capable of reflection. When we place daily life against this backdrop, perspective shifts gently. The concerns that fill your day still matter. Emotions, responsibilities, relationships, they are real, but they sit inside a much larger frame. The universe has been expanding for billions of years before you were born. It will continue long after your lifetime ends. This does not make your life trivial. It makes it precious. Briefness is not the same as meaninglessness. A shooting star lasts only seconds, yet it can leave a lasting impression. Your awareness, your thoughts, your experiences are brief on cosmic scales, but they are vivid. They are real within the time you have. Vastness also softens isolation. It is easy to feel alone in a world of billions of people. It is even easier to feel alone under a sky filled with stars. But the deeper truth is the opposite. Every atom in your body shares an origin with the atoms in distant galaxies. The same physical laws apply everywhere. The same expansion that stretches space between clusters also shaped the environment that allowed life to form here. You are connected not by proximity but by origin. The emptiness between galaxies is not separation in a human sense. It is spaciousness within a single fabric. That spaciousness can feel like breathing room. The universe is not crowded with intention pressing down on you. It is open. It allows room for choice, for growth, for stillness. When we understand that most of the cosmos is vast stretches of space, thinly filled with matter, the emptiness becomes less intimidating and more calming. There is space for everything. Space for galaxies to drift. Space for stars to form. Space for you to exist without being overwhelmed by the scale of it all. The expansion of the universe, which once sounded like something pulling everything apart, can also be seen as something creating openness. Darkness between galaxies is not a threat. It is quiet. It is the canvas against which light becomes visible. Without emptiness, structure could not stand out. Without space, stars could not shine distinctly. Without vastness, perspective would collapse. The size of the universe is not crushing. It is spacious, and within that spaciousness, there is belonging. You do not stand outside the infinite looking in. You stand inside it, resting within its openness. The 93 billion light-year expanse is not a ceiling above you. It is a description of the fabric you are part of. When you breathe in, the oxygen molecules entering your lungs were once in interstellar space. When you breathe out, those molecules return to the world. The exchange continues. You are not separate from the cosmos any more than a wave is separate from the ocean. And so humility becomes gentle rather than harsh. You are small, yes, but you are also an expression of something vast. Insignificance fades because belonging takes its place. You matter not because you are large, but because you are aware, because you can feel, because you can know. The universe is wide beyond comprehension, yet it is encountered through you, through your perception in this moment. That is not trivial. That is extraordinary. And when that realization settles, vastness transforms from something intimidating into something comforting. It becomes a reminder that you are held within a story far larger than your worries. That your life unfolds inside a cosmos steady in its laws and expansive in its scale. That you are a brief but luminous chapter in a narrative that stretches billions of years in either direction. The infinite is not pressing down. It is opening outward, and you are here within it, aware, breathing, part of the whole. Now let everything grow quiet for a moment. The expansion of space, the fading of distant galaxies beyond the event horizon, the ancient glow of the cosmic microwave background, the vast web of clusters and superclusters stretching across hundreds of millions of light years. All of it continues whether we think about it or not. The universe does not require our attention to unfold. And yet, here you are, aware of it. A conscious arrangement of atoms forged in long-dead stars, sitting on a small planet in a spiral arm of the Milky Way, within a universe 93 billion light-years wide. That number is almost impossible to hold in the mind. 93 billion light-years. Light itself, traveling at 300,000 kilometers per second, would need 93 billion years to cross that diameter. And yet that entire expanse, the observable universe, is something we can describe, measure, imagine. More astonishing still, it is something you can contemplate from the quiet of your own thoughts. The cosmos is immense beyond comprehension, but it is experienced through awareness. Through you, the galaxies drifting apart are not abstract concepts. They are ideas that have reached your mind. The expansion of space is not merely a distant process. It is something you can understand, reflect on, rest within. This does not make you larger than the universe. It makes you part of it in the most intimate way possible. The universe has arranged itself, through billions of years of evolution, into a form that can observe itself, into eyes that look up at the night sky, into a mind that wonders how large it all is. You are not separate from the infinite. You are one of its expressions. And so we return to something simple. The universe is vast. It is expanding. It contains trillions of galaxies, most already beyond our cosmic event horizon. It will grow quieter over unimaginable spans of time as light stretches and fades. Future observers may see only their local cluster, unaware of the greater structure we can still glimpse. We live in a rare era of cosmic clarity, an era when the afterglow of the Big Bang still hums across space, when distant galaxies still send their ancient light, when expansion can still be measured. That rarity does not burden us. It invites gratitude. You are alive at a time when the universe is still readable, when the sky still holds evidence of its beginning, when knowledge is possible. The infinite is not crushing. It is spacious. Most of the cosmos is not crowded matter, but open space, quiet, dark, expansive. That openness is not emptiness in a threatening sense. It is breathing room. It allows galaxies to exist without constant collision. It allows stars to form and planets to orbit in stability. It allows life to emerge in calm corners of spiral arms. The emptiness between galaxies becomes less like a void and more like silence between notes in music. Without silence, there is no melody. Without space, there is no structure. The vastness is what makes everything else visible. And beneath that vastness, you are here, breathing in air composed of atoms born in ancient stars, sitting on a world held together by gravity, orbiting a sun that fuses hydrogen into light. That light has warmed Earth for billions of years. It will continue to shine long after this night passes. Nothing about the scale of the universe removes you from belonging. If anything, it deepens it. You are not an outsider looking at a distant spectacle. You are woven into the same fabric. When space expands, it expands everywhere. When galaxies recede, they do so within the same physical laws that govern your heartbeat. The laws that describe cosmic expansion also describe the chemistry of your cells. There is no separation between you and the universe. There is only scale, and scale does not determine meaning. Meaning arises in experience. You are a conscious configuration of star-forged matter, aware of existing inside an expanding cosmos. That is not small. That is extraordinary. The observable universe may be 93 billion light-years wide, but it is encountered through the quiet space of your awareness. All of that immensity, the clusters, the voids, the dark energy pushing space outward, is something you can hold gently in thought. Let that settle. You do not need to grasp every number. You do not need to visualize every galaxy. You only need to feel the perspective. The universe is vast and steady. It was unfolding long before you were born. It will continue long after. And in the brief window of your life, you get to witness it, to know that you are part of it, to rest beneath it. So take a slow breath now. Imagine the night sky above you, not as something distant and cold, but as something spacious and calm. The Milky Way stretching in a faint band of light. Beyond it, other galaxies. Beyond them, expansion. Beyond that, horizons we cannot cross. And yet none of it pressing down on you. Only openness. Only room. The infinite is not a weight. It is a horizon. And you are resting safely within it. If you've made it all the way to the quiet edge of infinity, type 3 in the comments so I know you're still here with me. Now let your breathing slow. Inhale gently. Exhale softly. The galaxies continue their slow drift. Space continues to stretch. Stars continue to shine. And you, a conscious arrangement of ancient atoms, are here beneath the infinite. Let the vastness become calm. Let the scale become spacious. Let the night sky hold you, and rest.